Hello, good morning. Hope so that you all are doing well. In my previous lecture or first lecture, I have told you the history of Java, the features of Java, the uses of Java, and a little bit of JVM, JRE, and JDK. In this lecture, I'm going to tell you all of these three things briefly. Okay, let's start the session. What we are going to learn in this session: what is JVM, the Java Virtual Machine? What is JRE, the Java Runtime Environment? What is JDK? The Java Development Kit. How JDK, JRE and JVM runs all together so that it can successfully execute the Java source code. Okay. Differences between JVM, JRE and JDK. From job interview questions perspective and GATE exam or any other university exam, the 5 number question is so much important. Differences between JVM, JRE and JDK. So focus on this lecture. It will be important for you in the future. Understanding JVM, JRE and JDK. Okay, Java consists of three core components. As I have told you earlier, JVM, Java Virtual Machine, JRE, Java Runtime Environment, and JDK, Java Development Kit. Each of these three components has its own role in the successful execution of your Java program. The Java Virtual Machine, the execution engine, the main engine. The JVM, Java Virtual Machine, is an abstract machine that provides a runtime environment for executing Java programs. It converts Java bytecode into machine-specific instruction for execution in different operating system. JVM workflow, how JVM works. Class loading. The JVM loads compile.class file or bytecode into the memory. As I have told you earlier that everything in Java that you write will be converted into bytecode, and the file extension for that bytecode is .class files. And JVM loads that bytecode or .class file extension into the memory. Okay, bytecode verification. The JVM checks bytecode for security and consistency before execution. Suppose that your bytecode has any issue that can harm your system, then the JVM denies to run that code or bytecode. Just-in-time compilation. The JIT, just-in-time compiler, converts bytecode into native machine code for faster execution. You know that without machine code, your system will not understand anything. Your processor only knows machine code. That is, you can say, binary code. Execution, the converted code runs on your system software processor. Sorry, garbage collection. As I have told you earlier that Java has a Java has this great feature, garbage collection. There is a function in Java virtual machine which is called garbage collector. What it does, it checks periodically if there is any object which is not in use, then it deallocate the memory for that object. That is written here. The JVM manages memory automatically. So you don't automatically, what does this mean? You don't need to put any task, or you don't need to do anything. You don't need to put any code or anything else in your source code like C to remove that unused objects. Okay, JVM is included in both JRE and JDK. JVM is the smallest part, but the most important part. JVM is included in both JRE and JDK. JDK and JRE includes this JVM, the Java Runtime Environment for running Java applications. The JRE, Java Runtime Environment, provides everything required to run Java applications, but not for deployment. Development. It just only provide the runtime environment. It is only for running or executing what JRE includes. Okay. JVM. The most important thing, JVM, to execute the bytecode, to compile the bytecode into system understanding machine code, and it also has called Java libraries, Java API, configuration file for Java execution. JRE is a subset of JDK. It does not include development tools like compilers. As I have told you that it is not for development. It just only provide the runtime environment. It is a subset of JDK. JDK includes this JRE and JRE includes the JVM, the Java Development Kit, the whole package. Okay, the JDK, Java Development Kit, is a complete package. As I have told, it is a complete package, whole package for Java development. It includes the JRE, additional tools like Java compiler, debugger, documentation generator. What is this debugger? When you are going to run when you are going to write big complex problems, complex programs, in that programs, to run that program you will face many issues. For that you will need debugger. What JDK includes? JRE, as I have told you that JR, as in the previous slide I have had mentioned that JRE is a subset of JDK. It is also told here that the JDK includes JRE, Java compiler, that converts the Java source code that you write in your .java file extension into bytecode. Bytecode means .class extension. Okay. Debugger helps in debugging Java applications. When you're creating large applications, then you need this debugger. Java doc generates documentation from comments. Java archive, it is also so much important. Java archive, a jar file, is a package which includes which includes Java class files and resources, metadata, resources like image, configuration files, libraries. They're combined into a single file, and that is called Java archive. Why why the need of this thing? When you are creating large programs, it is easy to combine them into a single file and for easier deployment and distribution. JDK includes both JRE and JVM, making it the complete package for development. JDK includes everything, the JRE, JVM, for running your program, development, everything. How JVM, JRE, JDK all together, okay? Developer write codes. Use JDK, Java source code. Compiler converts code into bytecode. The JDK has compiler. That compiler compiles the Java source code into .class or bytecode. JVM inside JRE runs the bytecode. JRE provides JVM and libraries. JVM translates bytecode into machine code, and that bytecode is translated into machine understanding code by Java virtual machine. That makes it platform independent. Okay. Java source code .java JDK converts it, the compiler that is included in JDK converts it to bytecode, Java bytecode .class. Okay, .class file extension, platform independent code. It doesn't depend on the platform. If you're running on Mac OS, if you're running on Windows OS, and if you're running on Linux OS, it doesn't matter. There is a problem. Okay, let me solve it. Actually, it is not. It will be redirected to here. Okay, the Java bytecode platform independent code, then it goes to Java runtime environment. Java runtime environment has JVM and JIT, and JVM converts that bytecode into machine specific code or OS specific code. Program executes, then your program runs. And here is a practical example. I have written a source code, source file in Java. Let me change the color. Sorry. I have written a source file in Java, pass ob. Don't see the code right now. You will see. I will teach everything in the future. Just see that, and the extension for this file is .java. When I compile it from here, it creates this bytecode. The JDK, what it does, the code that I have written, it converts, first of all, it converts that file into bytecode through its Java compiler, and that Java compiler converts it converts the source code into bytecode, as I have told. And it what is done in the next, the JRE provides JVM and everything else. The JVM converts this dot class file extension or bytecode into .class. Here is the bytecode. .class file extension or bytecode into machine understanding code or machine code, binary code, whatever you say, what your machine understands. You repeat this. Okay, you write a source code, and the file extension for that is .java. You run that, you compile that, sorry, not run that, you compile that, and you will get that .class file. JDK converts it through its compiler, and the extension for that bytecode is dot class, and it goes to the runtime environment JRE. After that, the JVM converts it, the bytecode, to source code. Hope so that you have understand how things work. JDK, the whole thing. In JDK you have JRE, which has JVM and system libraries or APIs. As I have told you, JDK, the whole thing, JDK, and inside that you have JRE, Java Runtime Environment, which has class libraries and JVM included. And JVM is the most important part here. Actually, JDK is the whole thing. Inside that you will have everything: Java compiler, JHeap, JConsole, etc., and JRE also. Inside JDK, you will have JRE, Java Runtime Environment, which provide a secure runtime environment. Inside that, you will have two things: Java class library or APIs, and JVM, Java Virtual Machine. The Java Virtual Machine convert the bytecode into source code. What the actually does, you write the .java file here through the compiler. JDK converts it to bytecode. Then that bytecode goes into the JRE. JRE provides the runtime environment, and the bytecode then goes to JVM. Sorry for using the same color. The JVM converts it into machine understanding code or binary code. Okay, hope so that you understand everything, the workflow. Differences between JDK and JRE: used for developing, compiling, and running Java applications. It provides the whole environment. JDK purpose provides the runtime environment to run Java applications. It just provides the runtime environment, not the development environment. Remember that. Converts bytecode into machine code and executes Java program. JVM's work is to convert bytecode into machine code that the machine understands. That is how the Java is platform independent, because bytecode is platform independent. JRE includes, what this JDK includes: JRE, development tools, compiler, debugger. And what does this Java runtime environment includes? JVM and core Java libraries or APIs. And JVM, it is just the virtual machine for execution. Component, JRE, everything same. Required for developers who need to write, compile, and debug Java code. Yes, everything can be done through this Java development kit. But JRE is only users, for only users who only need to run Java applications. JVM, running Java bytecode on a system, can compile code. Yes, no, because they don't have compiler. No, only executes bytecode because it doesn't have compiler. Can run Java programs. Yes, obviously. Yes. Platform independent. Java programs written using JDK can run on any platform with JRE installed. Run Java applications on OS with JRE installed. Provides abstraction for platform independence. Actually, JVM, what it does, JVM is not, Java is platform independent, but JVM is not platform independent. It is platform dependent. JVM, how? JVM converts the bytecode into the machine understanding code in which JVM is installed. Okay, that's why JVM is platform independent, but Java is not platform independent. Bytecode is not platform independent, but Java is platform independent. If you install JVM, which is for Linux OS, in the Windows OS, it will not run. Okay, who needs it? Java developers, end users running Java applications like us, part of JRE, automatically run Java applications. Okay, let me remove the marking. Take a screenshot of this and just try to remember it. Um, it is so much important for you. Okay, thank you so much. And for this session, and hope so that we have a great time, and best of luck.